Hello class, so today we will look at another application of stack, right? So we will see at NGE, which stands for Next Greater Element. So the problem is pretty simple to see, but we will see how stack can actually help us to solve the problem more efficiently and in a faster manner. See, in computer science, there are various problems to which you can have a brute force solution. So by brute force, I mean you try all possible combinations and then you can check for a valid answer. So for example, when you have an ATM, so the pin is 4 digits, right? So the possible combinations will be you start from 0000 and you go up to 9999, right? So this becomes 10,000 combinations. Okay, so now let us say I want to try what is your ATM pin. So I insert the chip, I insert the card into the ATM, and then I start from 0000 and go up to 9999. Remember, there were old briefcases that had this 3-digit numbering from 000 to 999, right? In fact, it's available still now in the market. So now this is called a brute force approach, that definitely if you try all possible combinations, you will surely have one answer, right? But is it a good approach? No, right? Because like for example, in the case of ATM, your ATM will get blocked 3 times if you enter a wrong pin, right? So technically you will require 3,333 days to try all the possible combinations, right? More than 10 years, and by the time the card validity will expire. Right? So similarly, this application can be solved, which I am showing you. Next greater element can be solved using a brute force approach using for loops. But then we will see various examples and how stack can help us to solve the problem efficiently. See, when you see an example using 5 numbers or 10 numbers for depictive purposes, it feels that okay, even if you use 2 for loop, it will give an answer within a second. But imagine if you have 1 billion numbers, something of that sort, right? So first I will explain what is the problem and then we will look at. So for example, I have a set S of numbers. Let's say 10, 12, 1, 5, 4 and 7. Right? Sorry. So in the application, which is next greater element, so we have to take an element. Let's say the first element is 10 and find the next greater element to it. Okay. So let us change one number and keep this as 18. Okay. So now if you see, there are 2 numbers which are greater than 12, which are greater than 10. One is 12 and one is 18. Okay. So in the case of next greater element, we just need the first element which is greater than 10 and it is on the right hand side. So we will not search backwards. 2 conditions. First element which is greater than 10. So in this case, 12 and 18 are more than 10. But we will consider only 10 for our case, right? So now let us try this. So for 10, let us see for this question. So element, and I am writing next greater element. So for 10, 12 will be the next greater element. Now let us take 12. So for 12, 18 is the next greater element. So I will not even search further, right? Now for 18, there are no greater elements. 5 is less than 18, 4 is less than 18, 7 is less than 18, and we reach the end of the array. So for that case, we write as minus 1. Right? Now I am assuming only positive numbers. You can take some unique number, right? So let's say if there are less of negatives and positives, you can say, okay, the number 99999. If present, that means there is no element greater than that. Then let us say for 5, so if you go 4 is smaller, 7 is greater. Then again for 4, 7 will be greater. And for 7, the next largest element is minus 1. Always for the last element, because there are no elements beyond this, it will be minus 1. So this case is fixed. Right? So this is the problem and this is the expected output that we are expecting. So another example, let's say S1, we have 1, 2, 3 and 4. The numbers are in sorted order. So let us write element 1, 2, 3, 4 and next greater element. So we start with 1, go on the right hand side. Remember, we don't look backwards. So 2 is greater than 1, so next greater element is 2. Then we check for 2, next is 3. So for 2, the next greater element is 3. For 3, the next greater element is 4, and for 4, the next greater element is -1. So I hope the problem statement is clear as of now, right? So now we will see first a brute force approach. Always in computer science and data structures, we start with the most naive approach, right? So even if you give a class 6 or a 7 guy this problem, he will come up with this solution. So let us take a set S3, right? Let us keep some numbers 10, 14, 15, 1, 7 and 12, right? So these are the numbers that we are taking now. And now what we will do, a naive approach would be to run 2 for loops, right? So I will say loop L1 and inside I will have loop L2, right? Let us use the round bracket here. So what I will do in this loop, which I say as outer loop, I will take one element at a time, right? So I will keep 10 in the first case, and in the inner loop I will compare with all elements, right? So I will compare 10 with 14. Now 14 is greater, so this loop ends. Then I will have 14 here. I will compare with all remaining elements 15, 1, 7 and 12, and then I will write the output. So as you know, for loops right, so if the outer loop consists of, if the outer loop runs n times and the inner loop runs n times, the total number of executions will be m into n, right? Remember the standard. So if there are n for loops, it will be a into b into c into d up to n, right? So this is a very huge number, right? Assuming n to be 1 billion numbers, right? So and we assume as m is equal to n. So we say there are n square computations that are required to calculate this number, and which is a huge one, right? Let's say there are 1 billion numbers in the array. So it will be 1 billion square, 10 raised to 18. So that is too much of computation. Although you will get the right answer. The approach is not wrong. You will get the right answer. Now we will see how can stack help us. Or if you want to take an example for this understanding, let us take a sorted array. We have S4. Okay, sorted array but in descending order. So let us say 5, 4, 3 and 2. Right? So this is a array in a descending order, right? So we will write element here and then next greater element, and then we do a comparison, right? Number of comparisons required. So let's say when I write the element 5, right? So for 5 I need to compare with 4, it is smaller. I need to compare with 3, it's smaller again. I need to compare with 2, it is smaller again. Then I list end of the array. So next greater element is -1. Similarly for 4 I need to compare with 3. So number of comparisons I made is 3, right? Comparing with 4, comparing with 3, comparing with 2. So 3 comparisons. Next is 4. I compare 4 with 3, it is smaller, 2, it is smaller, end of the array. Now my comparisons is 2, right? When I compare 3, I compare it with 2 because we go only on the right hand side. It is smaller, end of the array, and then I have 1 comparison. And finally I compare with 2 because it is the last element. The next greater is -1 and I did not require any computation. So number of comparisons is 3 plus 2 5 plus 1 6, and which remains as 6. So 6 comparisons are required for 4 numbers, right? So this basically is so if there are n numbers, it requires n into n minus 1 by 2 comparisons, which is a huge number, right? So in this case n was 4. 4 into n minus 1 is 3 divided by 2, which gives us 6 comparisons. So also you can see here, if I expand this, this becomes n square minus n by 2, right? So the dominating term here is n square, right? So when n is very large, n won't have much of a difference. Okay, so when you have a quadratic equation, you say it's of the order 2, even though it may have a 0.1 x square plus 1 billion times x, but you say it's a quadratic equation, right? So you got this thing, that you remember just this thing, you required 6 comparisons here, right? Can we improve this, right? So there is an algorithm with which you can do it using a stack based approach. So what happens in a stack based approach? So now let us take another example for a stack based approach. So we will see 2 or 3 examples. So one a random number order, one in ascending order, one in descending order. So that will make the example pretty clear. So let us take another set S5. Okay. So first take us random numbers 10, 12, 8, 14 and 1. Right? And let us keep something like okay, this is 4 and let us keep it as 2. So what is the algorithm using a stack? So first step is initialize a stack. Okay, so what happens? So we initialize a stack here, right? So we start with the first element. When the stack is empty, you push the element to the stack. So we push the element 10 on the stack. This is the stack top pointer that I'm talking. And what are the remaining elements? 12, 8, 14, 4 and 2, right? So you start comparing 12 with 10. Now there can be multiple cases, right? We are assuming here that no elements are similar, right? Even that is there, that is not an issue. So now if you see the next element is 12, right? So 12 is greater than 10, right? Greater. So what we will do, we will pop stack. Okay. We will pop stack till the current element is greater than stack top, right? So if the current element, right? So this is the current element. So if the current element is greater than the stack top, right? 12 is greater than the stack top. That means, see, obviously also we see that 12 is the next greater element from this. So what we do, we pop the stack till current element is greater than the stack top. So we pop 10 and we say that current element is the next greater element. So what happens in our first case? So these are our results. So for 10, the result is 12. Now since that 10 is popped from the stack, right? The stack is empty. Now we go to the second element. Now we push 12 into the stack. Now since 12 is in the stack, our current element will be 8, right? Now what we do, we compare 8 and 12, right? 8 is less than 12, so of course it's not the next greater element. So since it is less, see, in our previous case, when it was greater, we pop from the stack. Now since 8 is less than 12, what we will do, we will push 8 on the stack, right? So what happens? In case of lesser, it is push. In case of greater, it is pop, right? Now we push onto the stack. Okay, 8 is gone. Now we come across next element. So what is the next element that becomes current element is 14. So now what is stack top? Because see, on stack you can have only operations on the top file, on the top element. So now 14 is greater than 8, right? This case only. And what I said, pop stack till current elements is greater than the stack top. So 14 is greater than 8. So that means for 8, the next greater element is 14. And that also you can verify. For 8, the next greater element is 14. So what happens? The stack top becomes on 12. Again we check because the current element is 14. So now 14 is also greater than 12. 14 is also greater than 12. So pop and store. So for 12 also, the next greater element is 14. So when you pop 12, the stack is now empty. So when the stack is empty, what was the current element? 14. That is to be pushed on the stack. So this number is over, this number is over, this pushing is over. Now we have pushed 14. Right? Now what will be the current element? The current element is 4. Okay, so current element is now 4. So what happens? 4 is less than 14. So push this case. Okay, so 4 is less than 14. So now we push 4 in the stack. Now what happens? What is the next element to be pushed? 2. Okay, so what happens with 2? Again 2 is less than 4, which is the stack top. See, we always compare the stack top. That's it. So 2 is less than 4. So what you do? We push 2 onto the stack. Right? So now what happens? The array ends. Right? So when the array ends, the last step of the algo is pop all elements and write -1 as next greater element. So let us see what will happen. Then for 2, the next greater element is -1. For 4, the next greater element is -1. And for 14, the next greater element is -1. Why did we pop up all this? Because we reached the end of the array. Now you can also verify. See, for 10, the next greater is 12. For then 8, the next greater is 14, because we always move on the right hand side and the first element. For 12, 8 is lesser, but 14 is bigger. But then for 2, 2 is anyways the last element, so the next greater is -1. Then we have 4, 2 is less, so for 4 also -1, and 14. Of course, 14 is the largest element, and then it is again the -1. So once again, the algorithm says that, so you keep element, first you take an element and push on the stack, and then you compare the stack top with the remaining elements one by one. If the element is larger, so what do you do? If the element is larger, so you pop the element from the stack, and the current element is the next greater element, right? And then you push the current element to the stack. If it is less, right? Less means we are still not able to find the largest. So we push the lower number onto the stack. Okay. So we will see 3 or 4 examples and then how it helps us. Right. So let us take another page. And S6, let us take like 8, 4, 7, 12, 15 and 3. Okay, so lesser is push, so just let me write, if less then push, more is pop. Okay, so now let us initialize a stack. I am having a small stack only because not many elements are kept, right? So first we are pushing 8 on the stack, right? I am ticking it above. So 8 is pushed on the stack, and this 4 becomes the current element. Now what we do, we compare 4, right? So let me write, okay, sorry, let me make a table here. Current element and stack top. So current element is 4, stack top is this. So what we will do, it is less, so push. So what happens, we push 4 onto the stack. Now the current element becomes 7. So current element is 7, right? Stack top is 4. So what we do, when it is more, we pop, and this is our list. Let us make this list here, right? The list will be next greater element, right? So for 4, the next greater element is 7. Okay, so now 4 is popped from the stack, right? So the number remaining is 8 on the stack. So now we compare. Current element is still 7, stack top is 8, it is less, right? So push on the stack. So what happens now? I will push 7 on the stack. Then current element will become 12, right? So current element is 12, stack top is 7, right? So stack top is less. Sorry, so 12 is there. So the current element is more. More means pop. And keep on popping till either the stack is empty or on the stack top there is a bigger element. So now what happens? 12 is bigger than 7. So what we will do? For the stack top 7, the higher element is this, and then we pop this, right? Now what happens? What remains on the stack is only 8. So now we compare 12 with 8 because current element is still 12. Again, 12 is greater than 8. So for 8, the 12 is the next greater element. So we pop it again. Now my stack is empty. Okay, the stack is empty. Now we push the current element. So current element is 12, right? We push the current element then, and now we come across 15. So 15 and 12, right? 15 is more, so we pop. So stack becomes empty. So for 12, the next greater element is 15, and then we push the current element on the stack, which is 15. Now next the current element becomes 3. So 3 and 15, right? This is less. Less means push on the stack. So we will push 3 on the stack. Once you push 3 on the stack, what happens? The array ends. So when the array ends, what do? You pop all. So you pop all and write -1 as NGE. So we pop 3. So we pop 3, which is mine, and write the next greater as -1. Then we pop 15. The next greater is -1. Right? So that is how you take out the next greater element using the stack approach. So you can see here we are visiting every number only once. We need not require comparing every number every time, right? So this is better cleared when we take a descending order array example, right? So let us take a numbers which are in descending order. So let us say S7 is 7, 6, 5, 4 and 3. Remember in the brute force example we require n into n minus 1 by 2 comparisons. Now let us do one thing. Let us design a stack. Right? So we have current element, and we have stack top. So more है तो pop, less है तो push. Right? So initially the stack is empty, so you push on the stack. So you push 7 on the stack, and then the current element is 6. What is stack top? Stack top is 11. So 6 is less than 7. So what happens? Less means push. So push 6 on the stack. Right? So how many comparisons I did? I did the first comparison. I compared 6 and 7. So I will just count the number of comparisons, right? So this is the one comparison. Now what is the next current element? Because 6 is already done. Current element is 5. Current element is 5. Stack top is now 6. Right? Since 5 is less than 6, push 5. Now we are pushing 5 onto the stack. This will become stack top. You made another comparison, which is the second comparison. Right? Now what happens? The current element becomes 4. Right? Current element is 4. And what is the stack top? Stack top is 5. 4 is less than 5. Right? Less is push. So push 4 onto the stack. So now I am pushing 4 onto the stack. What will be the stack top now? 4 is the stack top. So this was my third comparison. And finally, the current element is 3. What happens? So 3 and stack top is 4. 3 is less than 4. To push 3. So what happens? 3 gets pushed onto the stack. And this is the fourth comparison. Now what happens? End of an array. What do you do on the end of an array? You pop all end of the array, pop all, and next greater element is -1. You also can see here 7, 6, 5, 4. There is no greater element for anything, right? So how many numbers you had? 1, 2, 3, 4, 5. So n is equal to 5 numbers. And how many comparisons you required? N minus 1 comparisons. When you use 2 for loop, you had n into n minus 1 by 2 comparison, right? So this will be n square minus n upon 2, right? But in this case, it is only n minus 1. So if n is 1 billion numbers array, so in stack based approach, you will require 10 raised to 9 minus 1 comparison, and this approach you will require 10 raised to 18 minus 10 raised to 9 upon 2. So you see, this is a very, very greater number than this one. Okay. So hence stack is used here to find the next greater element, right? So this is an efficient approach, and I hope the algorithm is now clear, right? So right, last thing, when you pop all, so for 3, the greater element is -1, 4, the next greater is -1, 5, the next greater is -1, 6, the next greater is -1, and 7, the next greater is -1. Okay, that's it. So this was a small application of stack, right, that I wanted to discuss with you because this is a very important application, right? So this is for today's lecture. I will also discuss one more application of how can you use it for few more applications. I will try to cover one more application so that you understand, like, stack as a concept is simple, right? Push pop, there are only 2 operations, but where it is useful and why it is useful is more important to understand. Okay, so I hope you understood the example. So in fix to postfix, I hope it is clear. Next is this one, next greater element, and next we will look at some another application. Thanks for watching.